Welcome, folks. Today we're delighted to welcome Garett Kinnee to do a career spotlight on power engineering. If you're a student tuning in, please go to the Regina District Industry Education Council website and fill in a survey for a chance to win a $50 gift certificate and give us some feedback on how we can improve these presentations. With that, we'll head over to Garett.
So today I'm here to talk to you about power engineering. My name's Garett Kinnee. I'm currently a third class power engineer. We're referred to as a process operator, steam engineer. I obtained my power engineering diploma at Medicine Hat College. It would have been, I finished in 2009 now, so I've been in the industry for 13 years. Just a little background about power engineering. So typically we find employment in power generation plants, industrial facilities, and all types of residential and commercial buildings. Pretty much anything with boilers, steam, it's kind of where you'll find us. I'm currently in my 10th year with Yara Belle Plaine Fertilizer Production Plant, which is located in between Regina and Moose Jaw, just off the #1 highway. Our plant produces 3 different types of nitrogen fertilizer, anhydrous ammonia, granular urea, and urea ammonium nitrate. And we also produce DEF, or diesel exhaust fluid, which is a new additive for diesel engines to cut down on emissions. So that's kind of one of our newer things we've started a few years back. So at Yara Belle Plaine, we hire between 65 and 70 power engineers. Anywhere from our chief is a first class, and then shift supervisors are second class power engineers, and then the assistant shift engineers and process operators are all third class. And just a little more background, I've also worked in a canola crushing facility and a gas processing plant before I started at Yara Belle Plaine. So just kind of an idea how diverse the field is, where you can find employment. So education and training, 2-year diploma program offered tech schools and college typically. I know Nate, SAIT, and SAS Polytech all offer the course. I said I was at Medicine Hat College, and there's some other colleges that do offer it as well. You can too obtain your ticket through, it's almost like I'd say similar to like electrician or plumbing, where you put in time and can write your tests, but it's not the most I guess used route. It's a lot harder to actually get employment and work your way up through there, rather than having your 2-year diploma and already you can come out of school with a third class by obtaining your diploma. So that kind of fast tracks you. So it's not usually, you don't usually see that route taken, but it was more in the past before there's more regulations and stuff. So it is an option, but it's very rare these days, I guess you'd say. So 5 different classes of power engineers, 5th class and firemen's kind of is the low end, and then you work your way up to a first class. So that's this is all government regulated, so you must pass government tests to obtain your next class, along with the field experience. So with the 2-year diploma, the time you need in the field experience cuts down drastically to obtain your next class. So you can write for say my 3rd class, I had 4 tests, I had to write, and then put in 3 months experience. Whereas if I didn't do the diploma program and was just kind of doing it on my own, you're looking at more like 2 years experience. And it all depends on the size of plant and the heating capacity of the plant in order to obtain your next class. Obviously, that's something that has to be in consideration as well. So you look into your second class, and there's 6 more tests and more experience you have to obtain before you can get the second class, and into the first class where there's 8 tests and even more time you have to put in before you can obtain that next class. So with that goes more responsibility and more of supervisory and management positions as you get up into your second and first class. So like I said, government regulations determine what class of power engineer is needed. It's based on boiler and heating capacity of the plant or building. So you'd see a 5th class typically maybe in a larger residential building that has a smaller boiler they use for heat, or maybe a smaller old folks home where you're more of a building operator and doing maintenance, but you still need a firing ticket. And then all the way up to a first class, you're looking more at a large power generation facility or a larger processing facility similar to ours, or like an oil refinery. So yes, typically you see first class power engineers are in the management or supervisory roles. They're also referred to as the chief engineer. You need depending on what class your plant needs. It's typically a first class for the bigger ones. So you'll have a chief engineer who deals with more of your rules and regulations that have to be followed through the government. TSASC regulated, that's just kind of your boilers branch. They basically have rules and regulations you need to follow in order for safe and reliable operation of the plant, just so no shortcuts are taken and ensure safety is followed by everyone, and there's a standard for safety. Second class, yeah, you're looking more into supervisory and shift leads, and then third, fourth, you're just looking more at operators who are actually running the equipment and the control panel. So just a little more into education and training and where I work. Our power engineers spend about in between 9 and 15 months training in each of our areas in the plant. So we have 3 areas on my side of the plant that are we call outside areas, where you're actually out in the plant and you're monitoring equipment, checking temperatures, levels, pressures, checking on equipment, starting and shutting down equipment. So we have 3 different areas out there that each operator will spend 9 to 15 months in training. And then once they feel comfortable, they have to present a module to their peers where they have a sketch and have to do a written test and the presentation to the crew, just to prove that they do understand the process and prove that they're competent in being able to run all the equipment and doing startup and shutdowns in those areas. And then our final area is the control panel. So once you've worked through all the outside areas and are qualified in all the outside areas, your last area you will train on is the control panel. And it's kind of the same, 9 to 15 months. And then you have same thing with modules. And then you have one large test at the end, just to kind of tie everything you've learned over the last 4 or 5 years together to prove that you are a qualified operator and that you can work in every area in the plant. And with being qualified in each area, there you do see a slight pay increase. So that's kind of the motivation to keep going through all the areas. So duties of a power engineer. So we're responsible for safe operation and maintenance of large power and process plants, as well as building operators will be taking care of smaller buildings or heating plants or whatever it may be. So main duty, we want to maximize our plant production and efficiency. Obviously, the more production we can have at a lower cost, the better it is for the company, and probably the better it is for us personally, as there is some bonuses that are tied into plant production and efficiency. Equipment monitoring, we're checking on larger pumps, compressors, vessels, all sorts of rotating equipment. We have crushers, lots of screw conveyors. So we're just checking to ensure that everything's running smoothly there, and doing minor maintenance, whether it's greasing, adding oil. But yeah, we're mostly monitoring to make sure that temperatures, nothing's running too hot, or maybe there's looking for signs of failure. So you can be ready to isolate the equipment before it does fail, or notify the maintenance department so there can be a plan in place to fix the equipment rather than having a major failure, that type of thing. Chemical handling. So with lots of our boilers, they need chemicals for our water treatment. So we'll be batching certain chemicals to keep like our pHs and conductivity and excess oxygen in the water for our boilers, to keep them under control, just to help with preserve the life of the boilers, and so we don't have things like corrosion and scaling. So and then there's chemical handling in different parts, whereas in our lab test as well, we are using chemicals to determine what we're going to need to introduce for chemicals in our water treatment, as well as like other things such as our product quality. So which gets into product sampling analysis. We're always testing our product to ensure we've got the right chemical makeup, size, shape, even of our granules, all sorts of stuff like that, to ensure that we are on spec, so things can be shipped out to our customers. And then equipment isolation, it has lots to do with pumps, compressors, anything, even just clearing a line if there's a repair need to be done. We're making it safe for if it's maintenance, electricians, instrumentation. We're making the equipment safe for them so they can work on it. So if it's a process, we'll drain and clear the process and flush it out, purge it, ensure that there's no leftover liquid if it's a toxic chemical that was in the line, or even if it's water. You just want to make sure there's no pressure or liquid left in there, so you make it safe for the workers who are going to be performing the repairs on the equipment. So just to get into kind of where we work and the equipment and spaces we use. So control panels, you can kind of see the picture there. That's kind of the steering wheel of the ship, we'd say. It's probably the most important piece of equipment we have. So from the control panel, we can start up and shut down equipment. We can manipulate outputs of valves if we need them further open or closed. We get lots of temperature indications, pressure indications that read back to us, so we know what kind of moves we have to make to keep our product on spec, or if we are having an issue somewhere, to try and rectify the issues. So that's kind of the most important piece of equipment I would say we have. We also can kind of make out there, we have lots of trends that we run, so we know where everything's running at and trying to keep it within our safe operating parameters. Also, if there's something that's out of our safe operating parameters, we get alarms at the panel, so we know that something's maybe not running properly, and we can make a change to try and rectify that, or we'll get one of our field operators to go actually check out on it in the plant. And if they have to make changes out there to help out and try to get things back to normal, that's kind of the most important part there. Again, boilers and waste heat steam generation. That's the reason why we need a power engineering ticket, is because of the boilers. So we've got 3 boilers on site, and then we have multiple waste heat steam generators that use processed gas or excess heat from processed gas in and actually create steam from it, rather than just wasting the heat that we've made with our reactions. So our boilers are supplying steam to anything from just warm up. Some of our processes need to be at certain temperatures in order for reactions to happen. They also supply steam to our compressors, our turbines to spin our compressors. So that's another huge part of our steam usage is with their turbines to help spin our compressors. And then, just other process parts of the process that need excess heat. We use the steam from our boilers. And then, pumps, compressors, conveyors, and valves are all equipment we use on a day-to-day basis, whether it's pumping water to acids to even just other processed liquids. We have, I don't know how many tons, and compressors are kind of a larger part of our plant. We need to bump up the pressure of our process air and our process gases, whether it's CO2 or synthesis gas. We just need very high pressure, looking at like 15,000 kPa in order to get our reactions to occur. We need high pressure and temperature for our reactions to occur properly. So compressors are a huge part of that. And then conveyors, just to move our product, whether it's from the plant out into our storage shed. And then valves. Valves are everywhere, if it's for isolating equipment or to keep in levels and vessels in control, to drains. There's valves absolutely everywhere. So tanks, vessels, and coolers, they're pretty self-explanatory, just mostly for storage in our tanks, whether it's for storing acid we use in the process or acid we make in the process, to other liquids like our anhydrous ammonia is stored in a large tank. Vessels, most of the vessels are just for process, where lots of our process reactions are happening, are in larger vessels at high pressures and temperatures. And coolers, we have coolers, anything from coolers to cool oil down for pumps and compressors. We use a cooling water system on one side to pick up heat from the oils to keep them cold, obviously. So you're not creating excess heat on some of your equipment. As well as we do have coolers with that use large fans to cool our product down to a certain temperature before it goes out to storage. And then lastly, the lab analysis equipment. You can kind of see in the one picture there, we have anything from pH probes to conductivity probes, all sorts of different chemicals we use to determine our levels of anything from free ammonia in some of our water, all sorts of things we have to analyze and use different types of chemicals and different processes to figure out our levels and acceptable levels in our different processed liquids. So some other unknown duties, work permit issuing. So any work that goes on in the plant, whether it's mechanical, electrical, instrumentation, even scaffolding, you name it, if it's going on within our process area, we have to issue a work permit to the whichever trade it is. So it's basically setting out what the hazards are in the area, what you need to do as a worker to mitigate them, whether if you're working from heights, if you have to be wearing a harness, or if it's maybe it's a hazard that was inside a line, you have to wear different personal protective equipment. So we kind of lay out everything that they need to do in order for the job to go safely, as well as if they're working on a certain piece of equipment, we will lock it out for safety. So we'll put isolation valves and drains in the proper position in order to ensure that there is nothing that can get into the equipment while they're working on it. So it's ensured it's drained and depressured, so there's no chance of them getting hurt while they're, say, pulling a pump out of service. Also, we lock the breakers in the de-energized position so that there's no chance of any electrical energy hurting one of the workers while they're working on a piece of equipment, or so ensuring that a piece of equipment can't be started while the workers are working on it. Emergency response training. I'm not sure if this is at every plant, but at our specific plant, we do emergency response training for, we do it a few times a year, because any emergency there is on plant site, our operations teams respond to it. So anything from a grass fire on the outskirts of our plant to a medical emergency. We train in high angle rescue if a worker was to fall from heights. Anything to do with chemical releases, we train wearing the big funny nuclear looking suits, and we train under breathing air as well. So that's kind of something, it might be more specific to our plant, but it's kind of a different and cool training to do, a little outside of the normal work scope anyways. And then creating and updating of safe operating procedures. So we have safe operating procedures that we follow in order to ensure every startup and shutdown of equipment is done properly and to the safest as it can be. And so all of our workers are working under the same ideas rather than everybody doing it their own way. So it gives us a procedure that can be followed. So we're all doing it the same way and safely, and ensure that we're taking the risks out of doing most of the jobs. On the job training with new operators is a very large part of our job, especially with us. We're kind of a specialized process where most guys that are starting with us, or girls, sorry, have never worked in fertilizer production before. So there's a lot of on-the-job training, which I enjoy doing, but So it's anything from teaching new operators the safe operating procedures and going through startup and shutdown of equipment, teaching them about the hazards of the job, where if it's high pressures, temperatures, the hazards of certain chemicals we use, all sorts of stuff like that, which I really enjoy doing. So it makes the job a lot more fun and exciting, working with new people. Collaboration with other trades people. Day to day, we work a lot with electricians, instrument techs, millwrights. So it's kind of working and corresponding with them to troubleshoot issues that we find in the plant. It's kind of rewarding and gives you a different perspective and outlook, seeing it from their side of view. And yeah, it's neat to kind of see what other trades are doing and kind of getting a better understanding and background of their work. And then another duty is the lockout tagout procedure. So that's just for any maintenance that's going to be going on in our plant. We are locking out and putting tags on certain valves, breakers, start-stop switches to ensure that that piece of equipment is safe to be worked on. So some rewarding aspects of the job, working in a team environment. I really enjoy that part of my job. Realistically, the guys that are on your crew, you probably spend more time with them than you do your family. So getting along with the guys on your crew is a very large part of being a power engineer and being a good operator, even because if you don't get along with the guys you work with, it can be a long life for you. But yeah, growing up playing sports and just being in a small community where you need everyone working together to make things happen. It's one part I really enjoy about the job. It just kind of seems like you're back on a sports team or whatever, driving together to a common goal. So that's one part I really enjoy. Like I said earlier, training other operators, it's definitely fulfilling, and sharing your knowledge with new operators or even experienced ones that you might have more knowledge or background in certain things than they do. That's one part of the job that can be very fulfilling and rewarding. Continually improving the efficiency and production of the plant. That's a challenge I enjoy. Just any way you can find minor or major ways to make things better. And if it's more efficient or producing more, it's kind of one thing day to day that you're always trying to do. And it keeps you motivated to try and find new and better ways to do things. Troubleshooting process issues. That's probably the largest part of our job. It's pretty easy when everything's running smooth and steady and you're doing your day-to-day rounds and checks. But when you know what hits the fan, that's kind of when you actually show your worth at work. So troubleshooting to find the issues, what's causing the issues, to rectify the issues before there's something bad happens, or whether it's having to shut down the plant or a certain section of the plant. If you can rectify the issues before having to do something major like that, it's very rewarding, sometimes stressful, but very rewarding. And then just the different tasks day to day. It's one nice thing with our plant. There's some diversity. You're not always stuck working in the same area, doing the same jobs day to day. We kind of get to move around from different parts of the plant and working on the control panel. You're not just stuck in one spot. And it always seems like you're learning something new every day, or doing something different every day, or something different's giving you some issues or making you think. So just the challenge of that is kind of what keeps you going sometimes. So probably very well documented as a power engineer, shift work is a major challenge and stress. It does have some benefits, but you usually only hear the bad parts of it. It's tough more, as another point here, as social and family life stresses from the shift work. For me, you're working 2 out of 5 weekends, 1 of days, 1 of nights, 12-hour shifts. It's tough to balance stuff. Like for me, it's still playing sports. You're either trying to change shifts with the different guys so you can make games, or you're missing a lot of things, whether it's birthday parties, family gatherings, holidays even. But in the same breath, you are working 12-hour days. I work less days in the year. I have more days off than I work. So that's a nice part of the longer shifts. But it's one of the downfalls, but it depends who you are too. There's a lot of good things coming from shift work. There's lots of guys I work with that say they would never go back to a Monday to Friday 9 to 5 job, just with the amount of time off we get by working 12-hour shifts and days and nights. So it's you can take it both ways, I guess. Production targets, that can be a major challenge or stress if our plant isn't running well, or we're having issues with hitting our production goals. You definitely feel a little extra stress or pressure to get there, but that's kind of part of the business. You have to do whatever you can to meet those goals, and sometimes not everything works out right, and you feel a little bit of heat, but that's part of life. Another stress for sure is the risk with high pressure equipment and chemical hazards. One thing, there's little room for error. There's lots of safety measures that are taken, and there's government regulations and rules for high pressure equipment to ensure that everything is as safe as possible, but it's there's a little room for error. One valve turned open the wrong way, or one wrong move on the control panel could result in a chemical release, or release of high pressure gas, or even just equipment failure. There's always the risk. Obviously, we take lots of precautions with maintenance and different types of testing, but yeah, there's still the chance of equipment failure, which could result in personal injury. But for the most part, as times went on in the industry, that part of it has got so much better, and the risks are very minimal. I guess you'd say there's still high potential, but the probability is so low. So that part isn't maybe as bad as it once was. Maybe back, say, 50 years ago. There's definitely more regulations and rules from the governing body that help out with that sort of thing, but it's still always kind of in the back of your mind. So salary and benefits, I just went with a broad number there. So 80,000 to 200,000, depending a lot on experience and class of power engineer. Obviously, as you get up into the second and first class where you're supervising or in a management role, that number is most likely to go up and up. But yeah, it's very broad, and it goes along with where you work too, whether it's up, like there's lots of opportunity up north in Fort McMurray with in the oil sands with they use steam for oil extraction up there. Kind of get some of those guys get paid for living away and that sort of thing. So it's depending on where you want to work, what class you have, and kind of how tough the plant you're working at is. Going, say, from just a simple heating plant into a larger process plant, you're going to see a difference in pay there too, but probably a difference in stress as well. For us, extended health and dental benefits, basic life and accidental death and dismemberment insurance. We have short-term, long-term disability plan. We're on a defined contribution pension plan where our workers put in a certain percent of every check into the pension plan, and the company matches up to a certain amount. And then we also have an optional match savings plan, which kind of the same thing. The worker will put in a certain percentage of their wage, and the company will match it up to a certain number. And then as far as time off, we start with 3 weeks of a year vacation and 1 week of flex. So flex is you can either get an extra week of pay, or you can take the 40 hours and use it as vacation. And then another nice thing with years of service for us, after your 5th year, you accumulate an extra 8 hours per year of service going forward up to, I think, your 25th year. So little added incentive to stick around for the long haul that way. So some just supports and professional development. We have to keep valid first aid, WHMIS, workplace hazardous material, whatever. And then the transportation of dangerous goods, that all has to be kept valid. Government exams to gain a higher class of ticket. That's kind of after you come out of school, you would come out with your 3rd class ticket, and you can write your first 3 exams on your 2nd class. But once you're done school, you're kind of on your own going forward. So you have to study obviously on your own time to write those government exams. But our work's pretty understanding. You have lots of help and lots of guidance there. They're good with giving us the resources we need in order to study and obtain our next class of tickets. So that's nice. Just your general IT support help us fumble through all of our computer programs, and lots of our control panel stuff's pretty high tech. So having IT support there to get through working through some of those diagnostic issues is very important. And then I just put in here union and non-union workplace, depending on the owner of the plant and facility. Yeah, it just kind of all depends where you're working. There's not a union for power engineers, sorry, but depending on which plant you're working at, you could be in a union or non-union. Obviously, if the plant's government owned, that has a effect, or yeah, it just all kind of depends. But we're a non-union facility, but I know like you run into the SAS Powers and the co-op refinery. Those places all have unions, so everybody's got their preference on what they prefer. But I don't want to touch on that subject too much. So opportunities in the field. There's jobs in the field, many in remote locations, like talking about Fort McMurray's. You see lots in northern BC, Alberta, and Saskatchewan, just with lots of mineral exploration up in those areas. So there is some jobs in those areas, but obviously in maybe not the most desirable places to live. We are seeing some opportunities in Saskatchewan here with a few more canola crushing plants in the works. Also a few potash mines that are supposed to be coming online here. So there is some job opportunities opening up. At the same time, there is a bit of volatility in the job market with the push for greener energy. Obviously, coal power plants are trying to be phased out, which is a large part of our job market. Even oil and natural gas. There's lots of job opportunities with the extracting of oil and natural gases, or liquefied petroleum. Anything to do with oil and natural gas, there is a job opportunity. So with the move for green or greener energy, that part of the job market maybe is seeing a slowdown. But then again, they have to do something to supplement all of that kilowatts they'd be losing by shutting down coal. And if you're going electric, obviously you need more electricity. So there's hopes for more job opportunity with natural gas turbines to use to create power. I think there's a plant around Swift Current that was just built here in the last few years, and another one going up in Moose Jaw. So it's a little volatile with the green energy initiatives and kind of uncertainty there, but there's still lots of opportunity, and depending on what you want to do and where you want to work in the field, there's still opportunity out there for sure. So just advancement opportunities. Lots of the advancement is just as you gain experience in a higher class of ticket, that's the best way to advance yourself, whether it's getting your second or first class and moving into a supervisory or management role. Maybe if you're one of the people who don't like working shift work, that's probably your best way to get out of it, is getting into a management role where you're working 9 to 5, or maybe can be moved into a planning or different, or even coordinating training or anything like that. If you want to get off the shift work, gaining your next higher class of ticket is probably your best bet. And then it also gives you opportunities like working with the government. Our governing body is TSASC for our boilers and pressure vessels. If you again want to look at getting out of shift work, there's opportunities with them to be an inspector, other things like that, to kind of maybe get a more normal life, or more normal schedule. And then just some related fields to us, like I was talking about earlier, instrumentation technologists, electricians, millwrights. We work a lot with them and kind of have a good background of what they do, but it's just if you're interested in power engineering, or maybe you're in it and looking at something similar, or maybe not into shift work, if you want to still work in a industrial field, those are three good fields to look into. So work-life balance is very interesting. So for me, work 12-hour shifts, days and nights. There's very limited opportunity to work 8-hour days. There is some, but yeah, it is pretty tough to get on a Monday to Friday job. Weekends and stat holidays have to be worked depending on where you are in your schedule. For stat holidays, you usually end up working a handful a year. Weekends with our schedule, we work 2 out of 5 weekends. Lots of other places with 4 crews, you end up working every other weekend, but we run a 5-crew system, so we only work 2 out of 5 weekends. And our schedule is a little all over the place, so I won't get into how we swing from days to nights and days off, but it works out. We have a 5-week rotation, and out of those 35 days, we end up working 17 out of the 35 days. 10 are days, 7 are nights. As far as getting time off, we need a colleague to cover any shifts that we're trying to take off. But with that, you are overtime eligible for the shifts covered for vacation, as well as illness or extra help needed in the plant, where say if there's a startup of the plant, or they need just a couple extra guys for if there's a bigger project going on, you are eligible for overtime, anything over and above your normal shifts worked. Got anything else for me? Any questions?
Yeah, Garett, this is Gord talking. I just wanted to check. I thought the power engineers basically were in the room at Yara, but you sound like you go out into the plant and you're actually doing some physical work as well. I thought you were mostly monitoring the displays and stuff and the equipment. I know it's a huge responsibility monitoring all that, but do you guys go out and actually do some repairs as well?
Yes. So for us, we have 2 different parts of the plant. Each one has 2 panel operators and then 3 field operators. So our 3 field operators will go out and monitor the equipment, and we'll do small repairs. Anything larger will be for our maintenance staff. But yeah, we'll be out in the field clearing lines, blocking in valves and equipment, even just little housekeeping things, cleaning up. Yeah, so you're not just Homer Simpson all day, every day. There's actually some physical activity that goes on.
That's great. And then you said for classes, you're always learning. You're never done. What's your class now? What class are you up to?
I have a 3rd class, and I've been slowly working towards my 2nd class here. So hoping to start writing some more tests on my 2nd class.
Excellent. Technology wise, how has technology impacted your process? Like, it should be making it a lot safer. So if you can just speak to that a little bit, how technology's impacted your occupation.
Yeah, absolutely. With technology does come a lot of safety factors. So like even with the instrumentation we use now, whether it's temperatures or pressures, we have readings that come back to our control panel. And if say something went wrong and a temperature is going up at a pace where it's going to become a safety hazard. You'll hit a certain point where it'll take that piece of equipment offline, or several pieces of equipment that are related to that process, in order to keep things at a safe operating parameter. Or if you can't get to that safe operating parameter, it'll start shutting equipment down or taking gas out of processed gas out of the plant in order to keep things safe. So yeah, like we have lots of, we call them trips. So if you have too high or low of a pressure, temperature, or even levels, you have a reading out on your screen, and it'll actually take pieces of equipment offline and open and close valves to put them into a safe position so something catastrophic can't happen.
Well, thank you.
Hi, Garrett. It's Lisa Kuntz here. I'm the Chinook School Division Industry Education Program Facilitator. Thanks for sharing your stuff today. It was interesting for me to hear about the various industries that power engineering is used in. It's often associated with utilities, and it's way beyond that. And it's interesting for students to see that if you're interested in agriculture, you can be part of things. Or if you're interested in community work, utilities, a variety of things. I just have a couple of questions for you. The first one is about women, and it's how common is it for women to be in this industry?
It is becoming more common. Like, I know in my class I went to school with, I believe I had 2 out of 30 students were female, and from what I've heard with new operators at work, that number is going up. You're starting to see more and more females in the industry, and kind of like any other trade, really, whether it's electrician or millwright, we're starting to see more females in big industrial settings, which is a great thing. Currently for us, we have 2 of our power engineers are female, but it does seem like even when we have students in placements for a week, we do week or 2 student placements, we are starting to see more and more female power.
That's good to hear. Good to hear. My last question for you is a personal one. I'm wondering, how did you hear about power engineering, and what made you go into this field?
What got me into it actually was a roommate of my brother's. I was visiting my older brother, and his roommate had just finished power engineering, and I was in my grade 12 year and still kind of undecided on what I wanted to do, and just got talking with him, and seemed like something I'd be interested in, just with the whole mix of technology and moving equipment, and you get your hands into a lot of different things. I guess you say jack of all trades, master of none. So there's a lot of little pieces that you get to be involved with, but you're not really like you can work with electricians and millwrights and instrumentation and all those sort of things, but you're just seems like there's always something different happening every day, and no real one specialized area. So that's kind of what drew me to it.
Thanks. I'm glad you said that, because I think that we have lots of students who aren't really sure of what they want to do, and it was interesting to hear your path to choosing this career, and the fact that you find it rewarding, and it is a career that you're glad you made that choice, and you can shift to various industries should you choose to in the future. Thanks again for sharing.
You're very welcome. Any other questions?
Thank you so much, Garrett, for sharing your career journey with us. I'm sure the students will all find that very valuable in making their decisions.
I hope I wasn't too bad of a speaker. Like I said, I worked a night shift last night, so right now is about my 5 a.m. So I might not have been too sharp, but hopefully I got some points across and got a little information out there for the students.